This video lecture is going to cover how we classify equations as being either conditional, independent, or contradictions. The first type of equation we're going to look at is the conditional equation. These are equations that have a finite number of solutions, which just simply means that you can actually count the number of different solutions that will satisfy that particular equation. This is generally what we think of when we think of equations that we have to solve. We solve for the variable and we get an answer that is a number, real number or imaginary number, doesn't really matter which one. Or maybe we have a quadratic type equation and we solve it and get a couple of answers. Or maybe we have a polynomial equation and we solve it and get, 5 answers, for example. As long as you can count the number of answers that you have, it doesn't actually matter how many answers you have, okay? So an example of this would be maybe one of the just very, very, very simple, basic linear equations that we've been looking at in this section. This is probably even a little bit more simple than most of the ones that you have seen in the homework. X plus 7 is equal to 9. Okay, and we start solving it by isolating x. To do that here, all we need to do is move the 7. So we subtract 7 from both sides and have x is equal to a 2. Okay, well, that gives us a single answer, one answer. That is a conditional equation. Okay, next we're going to talk about identities. Identities are equations that have infinitely many solutions. They don't necessarily have to have all real numbers as a solution, but their number of solutions is not countable. So you may have infinitely many solutions over a certain interval, or you may have maybe all real numbers except a couple of certain values that don't work for that particular equations could be your answer. So let's look at an example of what that type of equation might look like. Two x plus 16 is equal to 2 times x plus 8. We would start here by distributing the 2 to begin simplifying. So 2 times x plus 2 times 8. And then a lot of times with identities, you'll notice at some point during the process of solving the equation that what you have on both sides are equal to each other, okay? If you do notice that, and there's not anything extra in the equation, then you can say at that point that it is in fact an identity. But let's say that you just don't notice, okay, and you start solving it. What's going to happen is when you go to subtract your x's from each side, you're going to wind up with a 0 where the x's would be on the left-hand side and a 0 where they would be on the right-hand side. Now this also happens in cases where we get no solution. The difference in the two is right here, what you get once the x's are gone. If what you get is a true statement, which it is true, that 16 is equal to 16, okay? If that's the case and you've lost your x's, then that means that this is an identity. Our last type of equation that we're going to look at in this little video is the contradiction. Contradictions are equations that don't have a solution. Now they work very similar to the identity in that you lose x as you work through the problem, but then what's left behind is not a true statement, it's a false statement, okay? So if what you get is false, then that is a contradiction, meaning that you have no, excuse me, no solution. Here's an example of that. 3x plus 14 is equal to x plus 10 plus 2x, okay? Combine like terms over there on the right-hand side. And then as with the identity, when you go to get rid of your x's, when you go to, not really get rid of them, but to move them to one side, you will get rid of them. They will disappear. They add out to 0 on the left, 3x minus 3x, leaving you with a 14. They add out to 0 on the right-hand side, leaving you with a 10. So what's left behind here doesn't make any sense mathematically. 14 is not equal to 10. So that is a false statement, which means that you have no solution. And this is a contradiction. And I believe I forgot to mention this before, but with the identity can be answered by writing down the interval over which x will work, if you can figure out what it is. In instances where it is going to be all real numbers, then you can just put all real numbers down for the solution. Some cases it's perfectly acceptable to just simply say infinitely many solutions. So that's what I'm going to do here. And that's how we'd write the answer for that one. Okay, so there are the three types or three classifications that we're going to use for some of the homework problems in this section.